Welcome back. This is Mr. Hassan's Math Channel, and I'm now answering question number 9 from the International A-Level, um, from the IGCSE Cambridge, paper 4, variant 2, the 0580 syllabus from October-November 2019. This is question number 9. It looks like it's got something to do with speed and time and distance. It says car A and car B take part in a race around a circular track. One lap of the track measures 7.6 kilometers. Car A takes 2 minutes and 40 seconds to complete each lap of the track. Car B takes 2 minutes and 25 seconds to complete each lap of the track. Both cars travel at a constant speed. Calculate the speed of car A. Give your answers in kilometers per hour. So we know that speed is equal to distance divided by time. Speed is distance over time. So we need to know the distance, which we know. So the distance is 7.6 kilometers, and the speed of car A, the time it takes for car A to complete this one lap is 2 minutes and 40 seconds. 2 minutes and 40 seconds. So what we need to do is, if we want to have the speed in kilometers per hour, we should make sure our units are in kilometers and hours. So the distance is in kilometers, that's no problem. Now let's change this into hours. In order to do that, first let me change it into 1 unit. So I know that 2 minutes is 120 seconds, so it's 120 seconds plus 40 seconds, so that's 160 seconds. And to change seconds into hours, I have to divide it by 160 divided by 60 and then 60 again, because I'm going from seconds to minutes to hours. So I'm going from smaller to larger, so I have to divide by 60 and then by 60 again. Alright, so that's divided by 60 times 60, divided by 60 squared. So that's going to give me the time now in hours. So I know my speed is equal to the distance, which is 7.6, divided by 160 over 60 squared. Speed divided by the time, the distance divided by the time. So you have 7.6 times 60 squared over 160, and that will give us our answer. So we have 7.6 multiplied by 60 squared divided by 160. And that gives us 171, exactly 171 kilometers per hour. That's the answer for part A. Now for part B, it says both cars start the race from the same position S at the same time. Find the time taken when both car A and B are next at position S at the same time. Okay, so basically they would have, completed, they wouldn't have, one car would have, lapped the other car basically, and they would end up being in the same place at the same time. So basically what we have to do is, they're actually asking us to find the lowest common multiple of these two times. Okay, we want to find the time where both those two times will first fit into. Okay, the lowest common multiple of these two times. So we got the time for A. Let me just get rid of this. We got the time for A, as we worked out, is 160 seconds. Let's keep it in terms of seconds. And the time for B, well, B's time is 2 minutes and 25 seconds. So you got 2 minutes and 25 seconds, which is 120 seconds plus 25 seconds, which is 145 seconds. So what we have to do is we have to find the not the LCM, the lowest common multiple, right? That's the lowest common multiple of 160 and 145. That will be the time that both of these fit into. Okay, so that will be the next time that they will be at the same position, when they've gone through, because they would have both gone through the same number of times. All right, different number of times, but they will both fit into that number. Okay, so that's the next time they'll be in line with each other again. So what we need to do is find the LCM of these two numbers. So let's look at 160 and break it down into its factors. So you can say 160, for example, is 40 times 40. 40 times 4, sorry. 40 times 4 is 160, not 40 times 40. 40 times 4, and 4 is 2 times 2. And you can say 40 is, you could say it's 10 times, or 4 times 10, just to give myself some more space. And this is going to be 2 times 5, and this is 2 times 2. So you have 2 times 2 times 2 times 2 times 2, which is 2 to the power of 5 times 5. And let's see if that works. Just make sure that we haven't made a silly mistake there. 2 to the power of 5 multiplied by 5 gives us 160. That's right. So we express this as a product of its prime factors, and we can take 145 and do the same thing. Okay, I'll do 145 in a slightly different way just to show you different methods. You look for the lowest prime number that goes into this, which is, I think, 3. No, 3 doesn't go into this, does it? Because that's going to be 5 plus 5, which is 10. No. So 2 doesn't go into it, 3 doesn't go into it, because the digits don't add up to something that's divisible by 3. But 5 is the first prime number that goes into it. 5 into 14 goes 2 times, remainder 4. 5 into 45 goes 9. 9 5s are 45. Okay, and that's it. 29 is a prime number. 29 goes into 29 one time, so you can say 145 is 5 times 29. So 145 is equal to 5 times 29. Okay, yeah, that's the answer there. Let me just make sure. 5 times 29, 145. So those are both prime numbers. So that just breaks up into 5 times 29. So we're looking for the lowest common multiple of 160. So 160 is equal to, as we said, 2 to the power of 5 times 5. And we've got 145 is equal to, we've got 5 times 29. All right, so to find the LCM, what we do is we take the things which are common in their highest form. So 2 to the power of 5, well, because there is also a to the power of 0 here, that's kind of common, but when we're looking for the lowest common multiple, we take whatever we see in its highest form. Put it that way. Whatever we see in its highest form. So 2 to the power of 5 times 29, that's going to give you the lowest common multiple of these two numbers. So let's work out what that is. We're going to have 2 to the power of 5 multiplied by 5 multiplied by 29. That gives you 4,640 seconds, which 4,640, sorry, let me write that properly. 4,640 seconds. So to make that into minutes, we're going to divide it by 60, which gives us 232. So let's write it as an improper fraction. 77 and 1/3. So it's 77 and 1/3. And 1/3 of an hour is, of a minute, sorry, 1/3 of a minute in seconds is 1/3 times 60, which is 20 seconds. So it's 77 minutes and 20 seconds. 20 seconds. Okay, so what we had to find was the lowest common multiple of these two numbers. That's the least number which they both fit into, basically. This question is basically asking you to find the LCM. You're finding a number that both these times fit into. The smallest number that they both fit into. So it's the lowest common multiple. So you can write them as product of their prime factors. I showed you two different ways of doing it. And then you can basically compare those prime factors and you write down whatever you see in its highest possible form. So 2 to the power 5 times 29. Okay. Okay, and that gives you the answer in seconds, which you can turn into minutes and seconds, dividing by 60, 77 whole minutes, and a third of a minute left. A third of a minute is 20 seconds. So there's the answer for that question, part 1 of B of question number 9. Now we're going to do question number 9B, part 2. It says, find the distance that car A has traveled in this time. So we know that speed equals distance over time. So distance is equal to speed times time. Okay, so we have here the speed of the 171 kilometers per hour. That's the speed of A. Okay, we already worked that out in the first part of the question. So speed is 171 kilometers per hour, and the time it's taken is 77 minutes, or we can say 4,440 seconds. 4,640, seconds, which is 4,640 divided by 60 squared hours. So the distance is the speed, which is 171, times the time, which is 4,640 divided by 60 squared. That will change it into hours. Just make that a bit neater. Okay, so that will give you your distance now in kilometers, and that's how we want the answer. So we take our distance, which is 171, and you multiply that by 4,640 divided by 60 squared. That will give you your answer, which is 220.4 kilometers. It's an exact answer, so I'll leave it like that. It's not something that continued on, so I don't round this to 3SF, because this is considered an exact answer. It stops there. All right, so it says the instructions are non-exact answers are to be rounded to 3SF unless otherwise specified. This is considered as an exact answer because it stops here. It doesn't continue on. Okay, so there's the answer to this question, which is question number 9 from October-November 2019. Paper 4 extended. Any other questions from this paper I will put in the playlist that should appear in this area at the end. Questions to do with, I guess I'll put this with speed, distance and time, travel graphs and things like that. You can find those in this playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.